This is a presentation how WebGL-Publisher and CADMAI technology can support web-based product configuration. It will cover aspects of different types of product configuration, like configure-to-order, assemble-to-order, or engineer-to-order scenarios. The focus hereby is not to present a full implementation of the different product configuration scenarios, but to show how our technology helps to implement these processes. Configure-to-order, CTO, is the manufacturing process of assembling and configuring products according to customer requirements. In web-based scenarios, a customer configures a product by entering configuration values like color or intended use. The CTO process uses rules to configure the product to meet the entered values. Hereby an overdetermined model is used, where specific substructures are activated, or deactivated. WebGL-Publisher technology supports this process by displaying the resulting end product in 3D. In this example, a shoe can be configured. The shoe consists of 3 components, a sole, a heel, and a vamp. Each component can have different materials. The heel is available in different forms. Beside the color options, for the sole additional material options like wood, metal, or acrylic are available. Selecting one of those also updates the model correspondingly. In addition to different materials, the heel is available in different shapes. To support this configuration, all heeled shapes are preloaded as 3D models in the background, and are dynamically assembled when the user selects them. For the heel, the same material options are available as for the sole, so it can be configured selecting the same material, or a different one. The assemble-to-order strategy allows a product, or service, to be made to specific order, where a large number of products can be assembled in various forms from common components. The WebGL-Publisher technology supports an interactive, customer-specific mounting using existing components in a website. In this example, a ring can be directly assembled by the user. All stone components of the possible configurations are preloaded and can be positioned to specific locations. The positioned stones can be configured using different colors. In addition to that, the orientation can be steered. While the dynamic mounting is performed, a bill of material is created parallel, which reflects the current product. Engineer-to-order is a type of manufacturing process, in which a product is designed, engineered, and finished, after an order has been received. The product is engineered to meet the specifications desired by the received order. This process leads to customer-specific parts, which cannot be pre-manufactured. CAD systems are used to design the geometry for these parts. Since most CAD systems support a parametrical design, an engineer does not have to start the modeling of the specific parts from scratch, but can use predefined parametric models, where the steering parameters can be adapted. To support a web-based creation of these customer-specific parts, a CAD engine must be steered remotely by the input from the web pages. The CADMAI and WebGL-Publisher technology support these processes by providing the web and CAD infrastructure. In this scenario, 3 processing levels are needed. The clients, where the configuration including the 3D models are presented. These clients use WebGL-Publisher technology to display the results. A provider, which distributes the configuration parameters, and sends the 3D models back to the clients. Multiple CAD processes, one for each active web page, which take the configuration parameters, generate the modified geometry, and export the model to a format a web browser can display. In this example, a gear rod should be configured. The parametric model is designed in CADMAI, and allows the change of the length of the rod, and the position of the screw sinks. To facilitate the geometric dependencies, the model has predefined parameters which steer the geometry. The length can be steered by this variable. The model logic allows only the creation of complete cogs, so the created length can differ from the input value. This sample shows the steering of the previously mentioned gear rod. When the web page loads, it asks the CADMAI web server add-in for a new CAD session. The web server add-in contacts the configured CADMAI CAD servers. One of the CAD servers create a new CAD session, which runs in batch mode. After the creation of the CAD session, the web page can steer the CAD session directly, using the web server add-in. In this example, the web page makes the CAD session to load the gear rod model, receives the 3D web representation, and displays it. The parameters can now be steered from the website, providing input fields for the values, or by clicking the dimensions in the 3D model. In both cases, the entered parameter values are sent to the remote CAD session, which recalculates the model with the given values, creates the web representation and sends it back to the web browser, which shows it. This presentation has demonstrated how CADMAI technology can be used to support product configuration in different scenarios. Since the WebGL-Publisher technology, as well as the CADMAI CAD framework, is embeddable into standard or customer-specific software applications, it can be used as an OEM software to help companies to digitalize their production process.